Chapter 1, Introduction to Embedded Systems. Here we are introducing what exactly the embedded systems means, what is the architecture of the embedded system, what is the classification of embedded systems, and what are some of the applications we can see in embedded systems. Let us begin with a small definition for the embedded systems. Embedded systems is a special purpose computer system which is designed to perform a dedicated function. It has a hardware part and a mechanical part. Basically, embedded systems is a combination of both hardware and software. Software to run the task, as I said, for a dedication function. So we have listed out some of the classifications based on how exactly the embedded systems is designed. The first system is standalone system. As the name says, stand alone. So this particular system works in stand-alone mode. It takes the input, it processes them, and it produces the desired output. So as I said, it's a combination of both hardware and software. To take an input and to give the output, we need a hardware, and to process whatever the data has been taken, we need a software. Coming to the real-time embedded system, it is working on real-time application and the input. Network information appliances. This is one kind of an embedded system which is working on a network-based interfaces like CLAN, Wi-Fi, or the telephonic network. Basically, we can call it as on we have an example like routers. Mobile devices, the fourth classification which we will list out. Mobile devices is a devices which has a mobility. For example, your mobile phone, your PDAs, your laptops. These are all like mobile devices. Mobile devices like your laptop can be listed in both networked and mobile devices. Okay, let us see how exactly the hardware architecture of the embedded systems looks. It has a central process unit system to process all the data. As I said, I need a input devices, output devices, and for example, if I want to run some application specific circuitry, like if I want to trigger any light or if I want to trigger any motor, so it has its own application specified circuitry. Communication interfaces, if you want to communicate with your computer, that we have like serial communication, UART, SPI, I2C, all this part. RAM, random access memory to store the data. Read-only memory, that is ROM, for your functions and software. So based on the requirement and based on the field, we have classified like in where all the applications we can see of our embedded systems. We can see in biomedical instruments. If I list out like your heartbeat sensor, SpO2 sensor, your temperature sensor, nowadays it is digital, your oximeters, your ECG. So these, if I list out this, it's a huge list. In communication system, your mobile phones, telephones, walkie-talkies, satellite communications, and many more. Peripheral controllers of a computer. If you can see, your mouse is embedded system because it has an input, it has output. Yes, there is something process happening inside it. When you click, it has to be right click. It has to decide which is right click or which is left click. So there is something program written inside. Boss, this is for right click, this is for left click, right? Then in industrial instrumentation, like you have robotic arms, PLCs. Coming to scientific, like your DSO, oscilloscope, logic analyzers. Coming to the domestic purpose, it is like your television, remote control, radio system, your MP3 players, computers, what all, right? So that's for today. Thank you.